These are notes for 3.7a, and 3.7 is probably the hardest section we do, I think, in the whole curriculum. So make sure you're not only writing them down, but really paying attention, or some of you might get kind of stuck in this section. And the reason is we are going to be adding, and in 737b, doing some subtracting. When the denominators, I'm just going to write denoms, the bottoms, aren't the same, that becomes much, much, much more difficult. So when the denominators were the same, we could just keep them and add the tops. But when the denominators are different, you already know how to do it when there aren't any variables. So let's do this one. Well, I don't like 2/6. Sorry, I'm going to make that a 5/6. We need to get what we call an LCD. We need the least common denominator, the smallest thing that both of these go into. They both go into 600, but that certainly isn't the smallest thing. And remember, the way we find that smallest thing is we go grab the big one and we see if it contains this one. If it does, then that's our biggest. If it doesn't, then we have to bump it up. And by that I mean if 6 didn't contain 3, then I'd have to do 6 plus 6, or 2 6s, and try 12. And if that didn't work, I'd do 3 6s. But you grab the big one and you keep pumping it up until it contains the other one. This one contains 3 right away. So what I'm going to do is leave the right one unchanged, because my LCD is 6 and that one is already over 6. But this one needs to be doubled. And you might say, LaRude, I know how to do this. And then we keep the bottom, we keep the bottom and we add the tops. And then we look to see if it simplifies. That's a 6, by the way. And it doesn't. And so we circle it. And I think you're very comfortable, you should be, with doing those. But when we add variables, for some reason, it causes lots of issues. So we're going to do this really slowly. By the way, the first 5 on your worksheet are basically just like this. So when you're doing your worksheet, I want you to keep your notes out so that you can kind of look and see how we did number 1 before you go do number 1, because these first 5 really mirror the first 5 on your worksheet. So I'm going to go through a 7x here. So what I need is an LCD. My LCD has to, and I go grab this 7x. Does it contain 7? The answer is yes. So what that means is 7x is my LCD. So I'm going to write each of these over 7x. That means this one, the second one, doesn't need to get altered. But the first one needs to have an x. And if I multiply the bottom by x, I need to multiply the top by x. Really, x over x is 1, just like right here, 2 over 2 is 1. I'm not changing the value of it. I'm just giving it a facelift so that I can have a common denominator. Once I have my common denominator, I keep it and I subtract the tops. And one thing that kids do right here that's wrong, a couple things. So I want you to put this in a box because it's done, and then I just want you to stare at it and listen to me. One thing that's wrong is to cancel those x's, because one of them is living next to a subtraction. The other thing that is wrong is to say that 5x minus 2 is 3x. In order for us to take 5 x's and remove 2 x's, we'd have to have an x on that too. Those aren't like terms. It's 5 x's minus 2 1's, and it's completely done. So no canceling right here, and no combining like terms on the top because they aren't like terms. It's done. Number 2, bumping up the difficulty a little bit. I've got 2 over 3x plus 12 plus 7 over x plus 4. I certainly don't have a common denominator, so I need to create one the exact same way that I did up here and right here. I grab the larger and I ask myself, does it contain an x plus 4? Well, we don't know that. Just staring at it, you might say no, but you need to, and if you read the directions at the top of your worksheet when you get it, it's going to say factor all denominators possible. So I want you to point at that. That needs to get factored so we can see what it contains. So let's go do that. I can factor a 3 out of it. And when I do, I actually do get an x plus 4. So my LCD is 3 times x plus 4. What that means is I'm going to rewrite both of these in terms of my LCD. This first one doesn't need to get changed because I want 3 times x plus 12. I had 3x plus 12, so I'm good. I can just leave that 2 right there. But the second fraction only has an x plus 4. So what that means is I need to multiply the top and the bottom by a 3. On the top, I get a 21, and on the bottom, I get 3 times x plus 4. Now that I have my common denominator, I keep it. And I add the tops. 2 plus 21 is 23. And I'm done because nothing else simplifies. And you can just leave it like that. You don't need to distribute this 3 in. It's not necessary. We actually like to see it in all of its factors. So those are the first two. Again, I'm going really slow here because this section tends to be quite difficult. So for number 3, 5 over x plus 2 minus 3 over x minus 3. So I grab the larger factor, which is x plus 2, and I ask myself, does it contain the other one? And it obviously doesn't. I mean, they're completely different. They don't factor any farther. So those are two completely separate numbers. It's kind of like if I did 1/3 plus 2/5. 5 does not contain 3. So what I need to do is use 15 because that's my LCD. I need to use the product of these two when they don't share a factor. So what that means is my LCD, just like on this one, is a 15, and this one will need a 5, and this one will need a 3. That's exactly what this problem is like. They don't share a factor. So my LCD is actually x plus 2 times x minus 3. It has to have both of them, and it's a minus. And on the other one, same thing. Whoopsie. So that's not very pretty. Let's go clean that up a little bit. Sorry about that. So I have an x plus 2 and an x minus 3. So what I need to go do on this one is I need to give each one of these what it does not have. X plus 2, got it. X minus 3, need it. So I multiply the top and the bottom by x minus 3 to create that LCD. X minus 3, got it. X plus 2, need it. So this one I multiply the top and the bottom by an x plus 2. So now what I've got is a common denominator, and I need to just go worry about my tops. This one would be 5x minus 15. This one would be 3x plus 6. Now that I've beefed up my tops, just like on this one if I made it a 5 and this one a 6, I keep that common denominator. Doesn't matter how ugly it is, once I have a common denominator, I'm going to keep it. And I'm going to go add up the tops. In this case, I'm going to subtract them. And you got to be really careful here because it's going to be 5x minus 15 minus, and I need to subtract all of this. So I've got to make sure I lock and load it in a set of parentheses. I'm running out of paper here. That's how long these are. So now what I do is I'm going to still keep that bottom. I'm just working right now on making it look pretty. I've got 5x right here minus 15, and then I've got minus 3x and minus 6. On the top of this fraction, when I go combine like terms, I've got 5x's minus 3x's, leaving me with 2x's on the top. I've got down 15, dropping 6 more degrees, so I'll be down 21. On the bottom, I have x plus 2 times x minus 3. And the top doesn't factor, and I can't cancel across subtraction, so I know I'm entirely done. Notice how much more difficult this is when we start making those denominators different. So I have 2 more to do. So these notes are a little longer, and the worksheet's going to take you a little longer. These are tricky. So again, I'm doing the first 5 basically on the worksheet you're going to do. I just changed them a little bit. So make sure you're writing everything down and listening really carefully. Next one. 2 over y plus 3 plus y over y squared plus 5y plus 6. Those totally aren't the same denominator, and they're ugly, but I need to know what my LCD is. So I grab what looks like the larger of the two, and I ask myself, does it contain a y plus 3? It's kind of like if one of the bottoms was 4 and one of them was 12. Does 12 contain 4? It does. So what that means is your LCD is 12. If I was doing it between 12 and 5 and I say, does 5 contain 4? The answer is no. So then I use the product of the two or any non-shared factors. All right, so let's go take a look here. I don't know if that bottom contains y plus 3 because it isn't factored. So I go and I see if there's any pair of numbers, and lo and behold, that factors into y plus 2 times y plus 3. So the question is, does this denominator contain this one? And the answer is yes. So really all I need to do to get my LCD is, do you have a y plus 3? Yes, I do. Do you have a y plus 2? No, I don't. So you introduce it on the bottom and on the top, just like you would if they were numbers. All right, so I now have my LCD of y plus 3 times y plus 2. So all I need to do is add the tops. Well, this top is 2y plus 4 plus y. It's almost as good as it gets, except 2y plus 1 more y gives me 3 y's plus 4 on the top. And on the bottom, and remember, we don't cancel when these are glued together with pluses and minuses. The only thing that's going to cancel this is if I have an entire 3y plus 4 on the bottom. Those are glued together, and you can't unglue them and start canceling parts of them. When there's a plus or minus, you need to see the whole entire factor to cancel it out. All right, this is about the longer set of notes I've done, but it's necessary in this section. So the last one is number 5. And then we're going to go see how it settles in when you go practice. So I have 2 over 4x plus, let's actually make that a 3. 3 over 4x plus 1 over 2x. And this one's actually a little easier because of the monomials down on the bottom. By that, again, there's no pluses or minuses. So I just go to the larger one and I ask myself, does it contain 2x? And the answer is yes. 2's in 4 and x is in x, so I've got containment. What that means is I'm going to just leave that first one unmessed with. This one, though, it's got the x, but it needs to be a 4. What that means is I'm going to introduce a 2 on the bottom, so I get it pumped up to 4x, and then I have to do it on the top. Now that I have a common denominator, I keep it and add up those tops, and I'm completely done. So that one wasn't too bad at all. So the worksheet you're going to go grab is worksheet number 11. It's tan. All right, so worksheet 11 is next. It is tan. 1 through 6 I want you to do, and then have me check them. If they're going really well, I might narrow the back side of it down a little bit. I don't know though, these require quite a bit of practice. You're going to have to really ace that for me to give you a little leeway on the back side. But while you're doing those, my 5 examples in your notes mimic 1 through 5 on this worksheet. So make sure you have the notes sitting out so you can kind of follow the process a little better. So good luck on this one. This is a hard one, guys, and I hope it goes well.